A very good morning to our lecturers, Arif Madangan and fellow friends. Today we are from Group C. We will present our mini project. Before we proceed to the presentation, I would like to introduce my group member first. The first one is Maliyanah Binti Jafry, Nadiansyah bin Yunaedi, Bryan Ong Yii Siong, Naavin anak lelaki Thirumugan, Ben Johnson Binsin, Debora Rongod, and the last one, myself, Nurul Syuhadah Binti Salim. Now, I will pass to the next presenter.
Hello, my name is Nadiansyah bin Yunaedi with matrix number BS 21110312. Today, we would like to present our discrete mathematics mini project, and I will start with question number 1, chapter 5, which is counting. So, for the first question, we are asked to count, which is in how many ways can a photographer at a wedding arrange 8 people in a row, including the bride and groom, if the bride must be the next to the groom. In this case, first, we need to count the 8 people with no restriction, which is 8 factorial, with the answer is 40,320 ways. Then, we need to count the 8 people with bride and groom together. We need to treat the bride and groom as one group. Now we have 7 objects to arrange the 6 individuals and the bride or groom's groups. There are 7 factorial, which is 5,040 ways to do that. Now, for each of those 5,040 groups, there are 2 possibilities, which is the bride and the groom, and the groom then the bride. That makes the total possible arrangement is 5,040 multiplied with 2. Then the final answer with the bride must be next to the groom is 10,080 ways. Next, for the question 1b, we need to count how many ways can a photographer at a wedding arrange 8 people in a row, including the bride and groom, if the bride is not next to the groom. So, in this case, we just need to know the amount of 8 people with no restriction, which is 40,320 ways, minus 8 people with the bride must be the next to the groom, which is 10,080 ways. So, the final answer is 30,240 ways. That's all for me. Thank you.
Question 1C. In how many ways can a photographer at a wedding arrange 8 people in a row, including the bride and groom, if the bride is positioned somewhere to the left of the groom? So, since we have 2 possible positions for bride to be positioned somewhere to the left of the groom, it will be C8 2 ways. We wish to arrange bride and groom in these 2 positions. Arrange bride on the left of the groom in 1 way, and the other 6 people in 6 factorial ways is given by C82 multiplied by 1 multiplied by 6 factorial will give us 20,160. Thus, a photographer can arrange 8 people in a row, including the bride and groom, if the bride is positioned somewhere to the left of the groom in 20,160 ways. 2a. Suppose that a password for a computer system must have at least 8 but no more than 12 characters, where each character in the password is a lowercase English letter, an uppercase English letter, a digit, or one of the 6 special characters. How many different passwords are available for this computer system? So, for a password for a computer system must have at least 8 but no more than 12 characters, which is we have 26 lowercase English letter, 26 uppercase English letter, 10 digits, or one of the special character, and which will give us 26 plus 26 plus 10 plus 6, in total 68. So we let k as the number of characters for a password give us 68 to the power of k. By using the addition principle, we add all the possible number of characters by using 68 power of k from starting from 8 to 12 will give us 9.92 exponent 21. Thus, we can have an approximate of 9.92 exponent 21 for different passwords available.
Okay, for question 2b, the question asks how many of this password contains at least one occurrence of at least one of the 6 special characters. So we can find the number of passwords with these characters if we subtract the number of passwords with no occurrence of special characters from the total number of passwords. So before that, in order to find the number of passwords without any special characters, we subtract the significant characters first. So we know that there are 68 significant characters. So minus 6 of the special characters, we are ended up with 62 characters. They are the capital letters A to Z, small letters A to Z, and also the digits from 0 to 9. So by applying the addition principle for length 8, 9, 10, 11, and 12, we get up to 3.28 times 10 to the power 21 passwords. So this number is the number of passwords without occurrence of special characters. So by subtracting the number of passwords with no occurrence of special characters from the total number of passwords, we get the number of passwords that contain at least one occurrence of at least one of the 6 special characters to be 6.64 times 10 to the power 21 passwords. Okay, question 2C. Using the answer of part A, determine how long it takes a hacker to try to check each and every possible password, assuming that it takes 1 nanosecond for a hacker to check each possible password. So from 2A, we obtain the number of different passwords for the computer system is 9.92 times 10 to the power of 21. So if one password takes 1 nanosecond to check, 1 nanosecond is equals to 10 to the power of negative 9 seconds. We will use up 9.92 times 10 to the power of 12 seconds. So we change that into years, it will give us 314,561.14 years. And this answer does not take leap years into account.
Question 3. The English alphabet contains 21 consonants and 5 vowels. How many strings of 6 lowercase letters of the English alphabet contain exactly 1 vowel? First of all, since it wants exactly 1 vowel, ways to choose exactly 1 out of 5 vowel, we will use combinations. Therefore, see, 5 is our N, 1 is our R. We will have 120 over 24 equals to 5 ways. Since it needs 6 letter strings, then there will be 6 positions for the chosen vowel. Then there will be 5 positions left to place the consonants since one of the 6 strings will be filled with vowel. Therefore, the ways to place consonants, we will use 21 power of 5 equals to 4,084,101. Hence, by using multiplication principle, 5 multiplied by 6 and multiplied by 4,084,101. Therefore, the answer will be 122,523,030 strings of 6 lowercase letters of the English alphabet that contains exactly 1 vowel.
3B, exactly 2 vowels. Step 1, since we want exactly 2 vowels, we will have 2 strings and repetitive words. Therefore, by using R combination, C and R equal n factorial over in a bracket n minus R factorial times R factorial, where R less or equal to n, we will get 15. Since there are 2 strings needed, ways to place 2 vowels in 6 lowercase letters is 25. Therefore, there are 4 strings left out to place the consonant letters, which is 194,491. Step 4, hence by using multiplication principle, the number of ways is 72,930,375 of 6 lowercase letters of the English alphabet contain exactly 2 vowels. 3C, at least 1 vowel. There is 21 consonant and 5 vowel alphabet. By adding these 2 different types of alphabet, we will get 26. Since there is 26 total of alphabet, ways for it to be in 6 lowercase letter is 308,915,776. Step 3, since there is 21 total of consonant letters, ways to be in 6 lowercase letter is 85,766,121. Step 4, since we want at least 1 vowel, by minus total ways of alphabet with total ways of consonant letters, the number of ways is 223,159,655 of 6 lowercase letters of the English alphabet contain exactly at least 1 vowel. 3D, at least 2 vowel. Since you want at least 2 vowels, by minus total ways of alphabet with total of consonant letters and ways of exactly 1 vowel, the number of ways is 100,636,625 of 6 lowercase letters of the English alphabet contain at least 2 vowels.
Question 1. Suppose that 150 people enter contest, that different winners are selected at random for first, second, and third prizes. What is the probability that Ahmad wins one of these prizes if he is one of the contestants? So first step, we will let S be the sample space. Then the cardinality of S equals to 150. Then we will let A be the event that Ahmad wins first prizes, and let B be the event that Ahmad wins second prizes, and let C be the event that Ahmad wins third prizes. Since we only want to find for Ahmad, then the cardinality of A, B, and C is equals to 1. Therefore, the probability of A, probability of B, and probability of C is equals to 1 over 150. So we will let B be the probability that Ahmad wins one of these prizes if he is one of the contestants. Thus, we will only total up the probability of A plus probability of B plus probability of C, and therefore the probability of P we will have 0.02.
My name is Bryan Ong Yii Siong, matrix number BS21110206, and I'm going to discuss about the question 2 of the chapter 6 of this assignment. And the question asks us about what is the probability that Ahmad, Farhan, and Siti win the first and second and third prize respectively in a drawing if 200 people enter a contest and no one can win more than one prize and another one is winning more than one prize is not allowed. So for the first one, the question A, for the first prize, there are 200 people that could win. So for Ahmad, he win the first prize, it will be probability goes to 1 over 200. And for the second prize, since Ahmad win the first prize, so there is 199 people left. So probability for Farhan win the second prize is equals to 1 over 200 minus 1, so it also equal to 1 over 199. So then for Slivia, is still same, use the step as the upper part. Slivia, the probability for her to win the third prize is 1 over 198. For the B, for them, the probability of them winning more than one prize is not allowed. So we just need to multiply the all probability for these 3 persons. So it is 1 over 200 times 1 over 199 times 1 over 198. So it equals to 1 over 7880400. So it is for the question 2.
Assalamualaikum warahmatullahi wabarakatuh. I am Maliyanah binti Jafry and my metric number is BS211100359, and I will answer for the question 3. So the question is, find the probability of each outcome when a biased die is rolled if rolling a 2 or rolling a 4 is 3 times as likely as rolling each of the other 4 numbers on the die, and it is equally likely to roll a 2 or a 4. So the solution is, let 1, 2 until 6 be the outcome of dice. Since rolling 2 or 4 is twice as likely as rolling each of the other 4 numbers on the die, and it is equally likely to roll a 2 or a 4. So the P stands for probability. Since probability will always equal to 1, then the steps are like shown above. We will get 10 P1 equal to 1, then P1 equal to 1 over 10. Thus, the probability of rolling each of the other 4 numbers is 1 over 10, and the probability of rolling the number 2 and 4 is 3 over 10. That's all from me.
Now,
it's time for Q&A session. Are there any questions?
I have a question about when do we use the multiplication principle in counting method?
The answer is we use the multiplication principle when using a step-by-step process to construct an activity.
I have question. When do we use addition principle in counting methods?
Okay, so when do we use addition principle? Addition principle is used when there is a disjoint set of objects and we want to find the total number of objects. Aside from question 2, chapter 5, that talks about the number of ways to find the passwords, we can use another example. Say a restaurant has 5 chicken dishes and 8 beef dishes. So when ordering, how many selections or options does a customer have? So by adding the 5 chicken dishes and 8 beef dishes together, we get 13 different choices a customer can have when ordering a dish. So that's how you use addition principle.
Next, for the third question is, what is the definition of conditional probability?
So, conditional probability is the probability of one event occurring with some relationship to one or more other events. For examples, event A is that it is raining outside and it has a 0.3, which is 30% chance of raining today. For the event B is that you will need to go outside and that has a probability of 0.5, which is 50%. A conditional probability will look at these two events in relationship with one another, such as the probability that it is both raining and you will need to go outside. Thank you. That's all from Group C. Thank you.